Hi dear students, this is the sixth part of fourth module of EST 100 Engineering Mechanics. In the last part, we have seen inclined projection on a horizontal plane and we have derived various equations used in that field also. Now we will do one problem regarding that type, that is inclined projection on a horizontal plane. The problem is find the least initial velocity with which a projectile is to be projected so that it clears a wall of 4 meter high located at a distance of 5 meter and strikes the ground at a distance of 4 meter beyond the wall as shown in figure. The point of projection is at the same level as the foot of the wall. So here, as you can see in the problem, it is clearly mentioned that the point of projection and where the projectile strikes are on the same level, and the other things given are we want to find the initial velocity of projection u, that is what is we want to find out. Then a wall is there at a distance of 5 meter from the point of projection, which is having a height of 4 meter, that is shown in the figure. So we are throwing the projectile with the initial velocity u at a particular angle alpha, so that it will be just clearing that 4 meter height at a distance 5 meter from the initial projection point, and after clearing that wall it should cover a horizontal distance of it should cover a horizontal distance of 4 meter. So in that figure you can see that the total range will be 5 plus 4 meter, that is equal to 9 meter. And if you are talking about a particular point on the trajectory P, then xy coordinates of that particular point P are x coordinate is 4 meter and x coordinate is 5 meter and y coordinate is 4 meter. So P is the point with coordinates 5 meter and 4 meter. The coordinates 5 meter and 4 meter. Now moving on to the solution, let u be the initial velocity required and alpha the angle of projection. In this problem, range is equal to 9 meter as I have told. Total distance, horizontal distance is 5 plus 4, that is 9 meter. So range is 9 meter. At point P, the x coordinate is 5 and y coordinate is 4 meter. So we have the equation of range r is equal to u square sin 2 alpha by g. By substituting in that 9 is equal to u square sin 2 alpha by g. From that you will get u square equal to 9g by sin 2 alpha. Keep it there as equation 1. Now from the equation of trajectory we have y is equal to x tan alpha minus half y equal to x tan alpha minus half 2u square gx square by cos square alpha. That was our equation. Now substituting for y equal to 4 and x equal to 5, 4 equal to 5 tan alpha minus half into g into x square, x it is 5, so 5 square divided by, instead of u square we are substituting from the equation 1, that is 9u by sin 2 alpha into cos square alpha, that is already there in this equation. That is, instead of this u square we are substituting from here, and cos square alpha already it is there. Now rearranging, we know that 2 sin alpha cos alpha equal to sin 2 alpha. Here you can see it is, this term is as such. Here sin 2 alpha is there in the denominator, lower part. So instead of that sin 2 alpha we will be substituting 2 sin alpha cos alpha. Therefore equation becomes 4 is equal to 5 tan alpha minus 25 divided by g and g cancel. So 25 square is 25 divided by cos square alpha is there, this is as such there, divided by sin 2 alpha is become 2 sin alpha cos alpha, 2 into 9 becomes 18. So equation takes in this form. Now 4 is equal to 5 tan alpha minus the other constants rearranged will give 50 by 18, that is total. This 2 is taken at the numerator, that 25 into 2 become 50, this 18 is there itself, 50 by 18. This entire term cos square alpha equal to cos alpha into cos alpha, so 1 cos alpha cancels, so cos alpha by sin alpha, it will be 1 by tan alpha, that tan alpha goes upward, so it becomes 50 by 18 tan alpha. So from that equation tan alpha is constant, tan alpha taken outside, so 5 minus 50 by 18 it will become 2.222 tan alpha. From that you can find the value of alpha, that is equal to 1.8, alpha equal to 60.95 degree. Now substituting for u square here, instead for alpha, here you will get, instead of substituting for this alpha you will get the value of u square equal to something. From that you can find the value of u is equal to 10.20 meter per second. Now the last case is, now the last case is case 3, inclined projection with point of projection and point of strike at different level. Initially, in the earlier case, we have seen that point of projection and point of strike are at the same horizontal level. Here, point of projection is at this point and point of strike is at this point, which is not in the same horizontal level. You can see that here there is a horizontal line. The point of strike is below the horizontal line and point of strike is on the horizontal line. So in the earlier case, as such in the earlier case, the projectile is thrown with an initial velocity u with an angle alpha to the horizontal. Let y0 be the distance below the horizontal line where the projectile strikes. That is, this point B is y0 distance below the horizontal line we have considered. So from this you can see that this is our y-axis. So anything below this line will be minus y. So y0 is actually negative. That keep in mind. These types of problem can be solved by using two methods. I will explain one by one. The first method is from the equation of motion in the vertical direction. As we have considered in the earlier case and all, we are considering here also the vertical motion. Let any point be p x y. Then we have the general equation y is equal to u sin alpha into t minus half gt square, that is s is equal to ut plus half a t square. That is the equation. So assume that y is somewhere here, this distance is y. Then we will take this distance is as vertical distance. Instead of that as we will be taking y, and vertical component of velocity u, the vertical component of velocity u is u sin alpha and horizontal component is u cos alpha. So here since we are considering the vertical motion, we will be taking u sin alpha into t means ut minus, since the motion is against gravity, minus half gt square, where t is the time to reach a particular point, y is the vertical distance. That's all. Now at the end what happens is, you can see that at the end at point B, y is actually this distance, that is minus y0. y I am taking minus y0 is below this horizontal line, that's why minus y0. So at point B the value of y is minus y0 and time to reach from A to B is nothing but the total time taken by the flight to strike the final point, that is time of flight. By definition it is nothing but time of flight. So at point B, at the striking point, y is equal to minus y0 and total time taken is time of flight. So substituting for this one, y becomes at point B, y becomes minus y0. This remains as such, u sin alpha into t minus half gt square, where you have to remember this t is actually the capital T, that is time of flight. From this equation you can find out the time of flight t. If u alpha and minus y0 is known, then we can calculate the time of flight t. Now we know that horizontal range is nothing but, since along the horizontal direction the velocity remains constant, therefore there won't be any acceleration. Acceleration is 0. So distance is equal to uniform velocity into time. Actually time to reach from A to B, horizontal distance to cover is time of flight. So horizontal range is the distance from this point to this point, that is horizontal distance, this horizontal level distance. So if you drop a vertical from B to this horizontal line, then the distance from this point to A, that is the horizontal range. So horizontal range is equal to horizontal component of velocity into time of flight. Horizontal component of velocity is u cos alpha. So u cos alpha into t. Actually this t is not small t, capital T, it is time of flight obtained from this equation. So by this way we can calculate horizontal range and time of flight we can calculate. Now next method is method 2. In this method what we will do is, we will be splitting the motion into two. That is, initially motion from point A to point C, that is maximum height point. From there C to B, again descending. Here it is ascending, here it is descending. So we will be splitting the motion into two. Now total time of flight can be split into two parts. T1, the T1 is the time required to reach the maximum height, that is point C, and T2 time required to descend from point C to point B. Now considering the vertical motion and noting that vertical component of velocity is 0 at point C, because at the maximum height point the vertical component of velocity is 0. So we are considering the motion from A to C. So we know that V is equal to u plus at. Here V is 0 and u is vertical component of u, that is u sin alpha into V is equal to u plus at. Actually A is minus g, so therefore minus g into T1. From that we can find out the value of T1 equal to u sin alpha by g. Now next is height reached in this time interval. So that is nothing but the total maximum height reached by the projectile. Height reached in this time interval, we know that s is equal to ut plus half a t square. So s here is h max. So instead of this h, actually it is h max. H max equal to u vertical initial component of velocity in the vertical direction is u sin alpha. U sin alpha into t1. T1 is the time to reach the maximum height that we have found out from this equation. U sin alpha into t1 minus half g t1 square. Actually minus is because motion against gravity. So from this equation you will get h max equal to u square sin square alpha by g minus actually this is instead of t1 we are substituting u sin alpha by g. So u sin alpha into u sin alpha, that is u square sin square alpha divided by g minus half into g this term square, that is u square sin square alpha by g square. So rearranging you will get h max equal to u square sin square alpha by 2g. Now while descending, that is the motion from point C to B, what happens is the vertical distance to be covered is h plus y0. The vertical distance to be covered is actually from here to here, from here to here. Actually the motion is from C to B, but the vertical distance to cover is from here to here. This is y, this one is y0. So the total vertical distance to cover is h plus y0 or h max plus y0. That is equal to again s is equal to ut plus half a t square. Now considering the vertical motion at the starting point is here, this is C. Here the velocity we assumed is 0, because if a projectile is thrown upward at the maximum height point, the velocity will be 0. So now we are considering motion from here to B. That means initial velocity at this point, that is maximum height point, velocity 0 means initial velocity at C is 0. Of course at B we will have a velocity. Now s is equal to ut plus half a t square. Now s is h plus y0 and u is 0. Therefore 0 into t2 plus half g t2 square. Here you note down it is plus half gt square, because the now from C to B it is downward motion with gravity. Therefore it is positive. Now from this equation we can find out the value of t2. Now t1 we can obtain from here, t2 we got from here, t1 plus t2 will be the total time. Now add both t1 and t2 to find the total time. That will be the total time of flight. Now if you want to find the horizontal range, r is equal to you multiply the horizontal velocity component u cos alpha into total time, that is t. R is equal to u cos alpha into t. This is the two different. One more method is the if anyone is interested you can go through the text. Anyway, what we are doing is we are using the same concept in the earlier part, but we are simplifying the problem with some assumption. That's all. We are splitting the problem into two parts and all. That's only we are using. So if you want to find some other quantities, we can use the earlier equation also, because if the problem we split is from here to here, here to here, then we can use all the equation that we have derived in the earlier, that is inclined motion on a horizontal plane, that we can use, no problem. But if you are talking about this much part, then we have to stick on to this equation. That's all. Now we will go through a problem. A cricket ball thrown by a fielder from a height of 2 meter at an angle of 30 degree to the horizontal with an initial velocity of 20 meter per second hits the wicket at a height of 0.5 meter from the ground. How far was the fielder from the wickets? That is the question. Now a cricket ball is thrown from the fielder by a height of 2 meter. Actually the fielder is throwing the ball from a height of 2 meter. From here he is throwing the cricket ball with an initial velocity 20 meter per second. We don't know at what angle he is throwing, but it hits the wicket at a height of 0.5 meter from the ground. I assume that this is the ground. This is 2 meter. Wicket is having a height of 0.5 meter. So he is throwing the ball from here. Actually angle is given. Is it given? Oh, sorry, alpha is also given, 30 degree, sorry. Cricket ball is thrown from the fielder from a height of 2 meter at an angle of 30 degree to the horizontal with an initial velocity 20 meter per second. Alpha and value u is given. So it is traveling along this curved path and it is striking exactly on the wicket at a 0.5 meter above. So the vertical height between the fielder from where he is throwing the ball to the top of the wicket is actually 2 minus 0.5. That is, this distance is 0.5 and here to here it is total is 2. So the distance from this point, vertical distance from this point to this is 2 minus 0.5, that is 1.5. Since this is our horizontal line, so anything below the horizontal line is minus, taken as negative. So actually y0 is minus 1.5. Now time of flight is given by the expression. Actually we are using the same equation, s is equal to ut plus now in this problem the given quantities are initial velocity u is equal to 20 meter per second and alpha equal to 30 degree, y0 equal to minus 2 minus 0.5, that is equal to minus 1.5, that we have already explained. So we have s is equal to ut plus half a t square. Now here s is nothing but from here to vertical distance travelled by the projectile is from this level to this level, that is minus 1.5 meters. So s is equal to minus 1.5. ut, u is initial velocity along the vertical direction, that is it is actually 20 sine 30, that is the vertical component of this initial velocity. So 20 sine 30 is the initial vertical component of velocity. So 20 sine 30 into t, where t is the time taken from this point to time taken by the boat to reach from this point to this point, that is total time of flight, we can say it is capital T. 20 sine 30 into t minus half g t square, because since it is against the gravity, motion is against the gravity for the majority portion, minus half g t square, minus half into 9.81 into t square. From this equation you can find out the value of t is equal to 2.179 second. Now once you got the time, now you can find the distance. Actually we want to find the distance between fielder and the wicket, that is this horizontal distance. Horizontal distance from here to here, this is nothing but the horizontal range. Horizontal range is calculated with the horizontal component of velocity into time of flight. Horizontal component of velocity is u cos alpha, that is 20 cos 30. So 20 cos 30 into time of flight you got is 2.179 into 2.179, 37.72742 meter, that is the answer.